All right, so here we go. Now we're going to do another example. So a couple of things to notice right away, right? So look at the equation and ask yourself which one is squared, which variable is squared. In this case here, the y variable is squared. So this is going to tell me that the axis of symmetry is going to be the y-axis in this case, right? So the axis of symmetry is going what? Left and right, which means that the parabola is also going left and right, okay? So immediately that's what I can say, right? So also what I want to do is now I want to put this in the right form, right? So I want to put this in y squared equals 4py, right? Because I want to know what p is, okay? So I'm going to divide everything by 2, and that's going to give me y squared is equal to what? 16x. And of course, I have to, 4 has to be a 4 needs to be a factor, right? So that gives me y equals 4 times 4x. So now I know that p is equal to 4. And p is also positive, which means that this is opening to the right. Okay? So now when I graph this, I have everything I need to graph it because I know p and I know the direction. Okay, everything else I can figure out. Okay, so I know it opens up something like this, right? Okay, and then the focus is going to be here, directrix is going to be here, right? So it's going to look like that. Okay, so now I know the distance here is going to be p, which means the focus has to be at what? It has to be at 4, 0. And then the directrix also has to be 4 units away from the vertex. So that means the equation for the directrix is going to be what? X equal to -4. And then also the axis of symmetry, what? The axis of symmetry has to be this way, right? And so the axis of symmetry is going to be y equal to 0. Okay? Now, also, let's talk about the latus rectum, right? So now in this case here, the latus rectum is going to be this line segment. Right? The line segment that connects, that's parallel to the directrix, right? But goes through the focus. So this line segment is called the latus rectum. And so one is to find the length, the focal diameter, which is the length of the latus rectum. And we also want to find these endpoints. Okay, so let's find the endpoints, because once we know the endpoints, we can figure out the focal diameter easily. So now, what we're going to do is we're going to stick in what? We know that the x, that the endpoints of the latus rectum are on the parabola and must have the same what? X coordinate, right? So these both have 4. We just need to find the y value. So now what I'm going to do is I'm going to just plug in what? 4 for x. So I get y equals 16 times 4, okay, which is going to be 64. So y squared equals 64. And if I take the square root of y, I get y equals plus or minus 8. And so this is going to be negative 8, and this is going to be positive 8. And so now I know the distance from the x-axis to both each endpoint is going to be 8 units. So that means that the focal diameter is 16. So focal diameter equals 16. And I think that's all the questions they want. Let me see here. So we graphed the parabola, we identified the endpoints of the latus rectum, write the equation of the directrix, did that, and the axis symmetry, did that, identify the vertex, did that. Well, the vertex is just the origin, 0, 0. The focus is at 4, 0, and the focal diameter is 16. We did that. Okay, awesome. That's it. Next, we'll talk about graphing parabolas where the vertex is located at other places other than the origin.